Okay, so hello everyone. I was gonna do a video on related rates, but apparently and unfortunately, I'm just not good at those. I'm gonna try again, like to practice with them again and see if I can post a video for you guys about those, but they are like really hard for me right now. So instead, what we're gonna do is we're gonna do critical points and finding the local an absolute extremum, or extrema of the points. So yeah, this is the problem I was working on, but I these are really hard. Um, so we're gonna do local extrema, or like extrema, basically absolute maximum and minimum, or minimum and maximum values. So, or otherwise called maxima and minima. So anyways, basically from algebra, or maybe college algebra, we learned how to find the minimum or maximum values of a function where it is of the form f of x equals ax squared plus bx plus c. We did that, and I'm gonna draw like two parabolas. So one looking like this, and this is the minimum, and this is the maximum. We also did in pre-calculus, we did like the difference between when we have a curve, right? So let's say we had something like that, right? So give me 1 second. Let me go ahead and try to sketch this. So here we learned that, basically, and let me actually, oh my goodness, give me 1 second, guys. I'm trying to see how I can actually sketch this really quick. So this is called an absolute maximum. And then this is called the absolute minimum. This is called the local maximum. And this is called the local minimum, otherwise known as relative minimum and maximum. Local equals relative, okay? Okay, sorry about that, everyone. So local is the same thing as relative. So local maximum, local minimum, yeah, we know that already. However, in calculus, we want to be able to find not just the local maximum and minimum of a quadratic function, but also the local minimum and maximum, as well as all extrema of basically of other curves like y equals x cubed, y equals, all those kind of curves, basically. So we're going to do some examples, and again, if, unfortunately, I don't know how to do related rates. I'm sorry, guys. I mean, I'm hopefully when I do get better at them, I can post a video about it, but they're very difficult to explain. I was not good at those when I was in Cal 1. So one of the first things about finding local minimum and maximum, though, is that we have to know how to find critical points. Now, a critical point, and maybe I can actually see if it's defined on here what a critical point is, because I'm not 100% sure exactly. So a critical point is wherever a local minimum or maximum happens. So for example, like if we have a function like this, let's say this is A, this is B, this is C, this is D. So here, 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 and here. These are what we call critical points. Okay, all of these. They're wherever on the x-axis, like they are where the local maximum or local minimum happens, or absolute maximum, absolute minimum, right? That is what a critical point is. Now, a critical point or a critical value is in terms of x. I think a critical point is in terms of x and y, but I'm not 100% sure about that. There's a difference between that and inflection points. Inflection points, I will go over it in the next video because I don't want to do too much in this video, but basically, critical points are where f prime of x equals 0. So where the rate of change is equal to 0. You see how here the rate of change is 0, and then over here the rate of change is 0. Over here the rate of change is 0, and over here the rate of change is 0. So that's what it's saying. That's what a critical point is. Now for this problem that we have here, or these three problems rather, it says find all critical points and use a graphing utility to determine whether the function has a local extremum of each of the critical points. So basically it wants us to find. Now there's a huge difference between finding increasing and decreasing intervals versus finding critical points and maxima and minima. Okay, so I'm gonna go first over maximum and minimum, right? So let's just say that we have the function in here f of x equals 1/3 x cubed minus 5/2 x squared plus 4x, right? And we want to find the critical points. And maxima or minima, or both, you know, or basically extrema. I'm just going to say extrema. Now I believe the extreme value theorem, and I don't think I went over this before, but extreme value theorem, hold on. Let me go ahead and just look it up online to see what it is. Okay, so it says, so I'm going to just define this very quickly. If it says if a function f is continuous from a to b, then f has at least one minimum value and one maximum value, on the interval a to b. So what does that mean? That means that if the function, so basically, let's say this is a, this is b. So for example, let's say here's a, and let's say here's b. And let's say this is kind of a function like this, even though I really doubt that there would be a function like that, but or actually let's do it this way, like that. So you see that in between a and b, the function is continuous on this interval, and that the minimum and maximum values, this is a maximum value, and this, or sorry, not that, this one is a minimum value. That is what the extreme value theorem says. Now there's a difference, and maybe I can actually, hold on, maybe I can actually do this a little bit more differently. So give me 1 second, guys. I'm trying to see how else I can define this. So basically, it means that there's at least one maximum and minimum. Now, it can have multiple. There can be a maximum here, a minimum here, another maximum here, another minimum here, etc. But that's what the extreme value theorem says, is that between a and b, between the intervals of a and b, there has to be at least one maximum and minimum value. So yeah, that's what that's saying. Now, let's see. Now looking at this, basically looking at this function here, what you have to do to find the critical points and the extrema is you have to first find f prime of x, okay? So f prime of x is going to be equal to, and it's going to be 3 times 1/3 x to the 3 minus 1 power minus 5 halves, or actually it's going to be minus 2 times 5 halves raised to the x to the 2 minus 1 power, and then plus, and then the derivative of 4x is just 4 because that's the slope, right? So f prime of x is equal to x squared minus 5x, and then plus 4. Now, to find the critical points, you have to set f prime of x equal to 0. So set f prime of x equal to 0 to find critical x values, right? So here we have, so it's going to be x squared minus 5x plus 4, and then let me put and solve for x to find critical x values. So basically we have, so it's going to be this is going to be equal to 0. So then we have that x minus 4 times x minus 1 equals 0. So that means that x equals 4 and x equals 1. Now, to find critical points in terms of x comma y. So let me see, give me 1 second, guys. Okay, so actually those are the critical points. These are the critical points of f of x, right? So we have one part done for this. So it basically wants the critical points, and it also wants the extrema. So number 3, to find extrema, draw a number line. So we're going to draw a number line, and this is where we really have to pay attention, because this is what they do in calculus to find the extrema. So what you're going to do, you're going to go from negative infinity and then to 1, and then from 1 to 4, and then from 4 to infinity. Now you're going to go ahead and for the derivative, you're going to find, so find where f of x is increasing or decreasing. What I mean by that is, so choose a value between the intervals negative infinity to 1, union 1 to 4, union 4 to infinity. Okay, so what you're going to do, and this is something that we really have to pay attention to, because some people confuse this in the other way. They would say to find the intervals of increasing and decreasing, or not the intervals of increasing and decreasing, but to know where the function is increasing and decreasing, they confuse, like, instead of actually evaluating it for f of x, or for f prime of x, they do it for f of x. So what you're going to do is you're going to go ahead and say, so basically we're going to first do the interval. So here's going to be the interval. This is going to be f prime of x, and this is going to be positive or negative. So from the interval, and actually let me do it this way. Preferred x value. So what you're gonna do, and hold on guys. What you're gonna do is you're gonna go ahead and so take negative infinity to 1, and you're gonna choose a value between those two intervals. So, or between that interval. So let's say I choose, I don't know, x equals, let's say I choose x equals 0, because it's between, so it goes 1, 0, negative 1, negative 2, negative 3, so I can choose x equals 0. Now I can do the evaluation, so f prime of x, and I can state whether it's positive or negative. So then I can say f prime of x for this is going to be, so 0 squared minus 5 times 0 plus 4. So then I get 0 minus 0 plus 4, which is 4, so it's positive. So I can state that between these two intervals at x equals negative 1, or sorry, at x equals 0, it is positive. Now I choose, then I do from 1 to 4. So then I say from 1 to 4, the x value that I can choose between that interval, I can choose x equals 2. So then I do it, 2 squared minus 5 times 2 plus 4, 4 minus 10 plus 4, that's going to be 4 minus 6, which is negative 2. So that's negative. So here, it's going to be negative. And then from 4 to infinity. So 4 to infinity, if I do 4 to infinity, I can say x equals 5. 5 squared minus 5 times 5 plus 4, that's 25 minus 25 plus 4, which is 0 plus 4, which is positive 4. So that's positive. So that means that over here it is positive. Now what does this mean in terms of, and let me actually label the numbers here. These are just the numbers that I chose, right? So 1, and then I chose, so let me go ahead and do it this way. Hold on, guys. So here I chose from, from negative infinity to 1 at x equals 0, the function, or the derivative of the function, is positive. So that means, because the derivative is known as, we know the derivative to be, so we know the derivative is the rate of change, really. So what does that mean if the rate of change is positive? That means that at x equals 0, the rate of change is positive, and the derivative is positive. So it's increasing. It's increasing. It's increasing. And then that means the function is increasing. At x equals 2, because we chose x equals 2, the rate of change is negative, right? So here it is negative. So this means it's decreasing. And at x equals 5, we said that the rate of change is positive again. So that means that here, from 4 to infinity, it is increasing. So what does that mean? That means that that f of x is increasing from, so it is from negative infinity to 0, union 4 to infinity, and it is decreasing from 1 to 4. Okay, that is how you find the intervals of increase and decrease. And now to find the maximum and minimum, we know that the function, so if I do like a little, if I even do over here on the number line, let's say I do increasing, so it goes like this, and then it decreases again like this, so it decreases again like that, and then it increases back up again. So really, if I draw the graph, or if I do a little sketch of this representation, and I do x equals, so x equals 0, x equals 2, so, or actually, from x equals 0 to x equals 1 to x equals 4 to x equals, so then, and then forward to infinity, I can say that or actually, let's make this negative infinity like this, so that way it looks like it's, so basically we said that it's decreasing, or it's increasing from negative infinity to 0. So it's going something like this. So you see how it's increasing, right? It is increasing. And then we said also it is decreasing from 1 to 4. So or actually, hold on. I'm sorry, I meant to say negative infinity to 1. Oh my goodness. Not negative infinity to 0. Negative infinity to 0 is, because I chose 0 as my x value. That's why I put negative infinity to 0. It's really negative infinity to 1, because that's the interval at which it keeps going, right? From the critical points that we got. So then it would be from negative infinity to 1, it'd be going like this, right? And then from 1 to 4, it's actually decreasing. So it's actually, let me do it this way, hold on. And then from 1 to 4, it's decreasing. And then from 4 to infinity, it is increasing again. So you see right here, if it is increasing from 0 to, so if it's increasing from negative infinity to 1, that means that there's going to, if it's going increasing and decreasing, that means there's going to be a maximum. So it goes like this, and then it goes like that, from negative infinity to, and let this be 1, and then from 1 to 2, it's decreasing, and then from or not 1 to 2, sorry, from 1 to 4, and then from 4 to infinity, it's increasing again. So here, we have a maximum between negative infinity and 1. So the maximum is going to be located at x equals, at x equals 1. And also, or no, it would just be at x equals 1. The minimum, and let me actually, the minimum would be, so let's see here, hold on, give me 1 second, guys, I'm trying to make sure. So the minimum would be at x equals 4. Now, if you want to find the full point, you're going to have to plug those into the original function, not the derivative. The original function that you had, you're going to have to plug those points in. But I don't think that they make you find the full maximum and minimum. But yeah, that's how you would do it. So let's do another problem, okay? I feel like yeah, this was just one problem, but I want to do another one so that you guys can understand a little bit better. So give me 1 second. I'm gonna come up with a problem here. So give me 1 second, guys. Okay, so for this one, we have find the minimum. Oh, and hold on. Okay, so for this problem, we have find the minimum or maximum values of f of x equals 2x cubed minus 12x squared plus 18x, and find the intervals of increase or decrease. Okay, so the way that you do this one is you have to first, so number one, set f prime of, so number one, find the derivative of f of x. So the way that we do this is f prime of x. We're going to say, so remember, it's 3 times 2x to the 3 minus 1 power minus 2 times 12x to the 2 minus 1 power plus, and then the derivative of 18x, or the slope of 18x is just 18, right? So then we have the derivative is going to be 6x squared minus 24x plus 18. This is f prime of x. Now number two, set f prime of x equal to 0 to find critical points. And by critical points, I mean x values, okay? So we're going to set this equal to 0. So basically this function here, we're going to set it equal to 0. So we have 6x squared minus 24x plus 18 equals 0. We can divide both sides by 6 because it factors out. This is 6 times x squared minus 4x plus 3 equals 0. If we divide both sides by 6, we get x squared minus 4x. Oh, and by the way, it's supposed to be, actually, oh wait, I'm correct. It's x squared minus 4x plus 3, because these two cancel out, yeah, equals 0. Sorry about that, guys. I was getting kind of confused for a second. And then you're going to set it equal to 0, and you're going to solve for x. So I forgot to put and solve for x. So you're going to solve this for x. If you know how to factor, you would get x minus 3 times x minus 1 equals 0. That means we have x minus 3 equals 0, or x minus 1 equals 0. So then by the zero product property, we solve each one for x. So we have plus 3 on both sides, x equals 3, and then for the other one, plus 1 on both sides, we get x equals 1. Now, those are the critical points. The critical points are x equals 3 and x equals 1. So now, we have to find the minimum and maximum values. So, the first thing that I really recommend you do first, is find the intervals of increase or decrease. Now you're going to draw a number line. Again, we're going to draw a number line, and we're going to go from, so the intervals of this is going to go from negative infinity to 3, or actually, hold on, negative infinity to 1, union 1 to 3. So it goes negative infinity, and then you're going to go from lowest to highest. X equals 1, and then x equals 3. And then infinity, right? So this part is denoted as negative infinity to 1. This part is denoted as 1 to 3. And this part is denoted as 3 to infinity. Okay? That's what you have to know. And that's how you set it up when you do the number line, right? Now, so let's see. Those are the critical points. So x equals 1, x equals 3 are the critical points. And now you're going to test, so number 3, test from negative infinity to 1, excuse me. So test from negative infinity to 1 for f prime of x, and to find if f of x increases or decreases. What I mean by test is test an x value. So test an x value from negative infinity to 1 for f prime of x to find if f of x increases or decreases at negative infinity to 1. So we're going to do f of negative 2, right? So if we do, or actually we're going to do f prime of negative 2, sorry. So f prime of negative 2, that's going to be equal to, or we'll do f prime of 0, actually. F prime of 0. Right? If we do that, it'll give us 0 squared, so it's going to be, so our derivative, f prime of x, so remember, f prime of x is 6x squared minus 24x plus 18. F prime of 0 is going to be 6 times 0 squared minus 24 times 0 plus 18. So you have 0 minus 0 plus 18. This is just 18. So it's positive. So we know that it is positive there. Now, what does that mean? That means that here it's increasing from negative infinity to 1. It is increasing. Now, so it's increasing from negative infinity to 1. Now, number 4, test an x value from 1 to 3. So, like the interval from 1 to 3. So we can choose x equals 2. So f prime of 2 is going to be 6 times 2 quantity squared minus 24 times 2 plus 18. This gives us 6 times 4 minus 48 plus 18. This is 24 minus 48 plus 18. So this is going to be negative 24 plus 18. So we already know it's going to be a negative number. So up here we put negative right here. Okay, this is negative. And then we test, so number 5 Number 5, test an x value from 5 to infinity for f prime of x. So f prime of, let's just say 6, that's going to be, so 6 times 6 squared minus 24 times 6 plus 18, that's going to be, so let's go ahead and do that on the calculator. So let's see, it's going to be, 6 times 6 squared minus 24 times 6, hold on, minus 24 times 6 plus 18, so that's 90. So that means that here it's going to be positive, right? So here that's positive. Now, looking between these intervals here, we know that because here it is negative, this is decreasing. It is decreasing from 1 to 3. So basically, and then from 3 to infinity, it is increasing again. So the intervals of increase or decrease it is increasing from so it is increasing from negative infinity to 1 union 1 to infinity, and it is decreasing from it's going to be decreasing from 1 to 3. So these are the intervals of increasing and decreasing. Now, looking at the maximum and minimum, we know that because it is increasing from negative infinity to 1, so it goes like this, right here. You see it's increasing, and then it's decreasing from 1 to 3. So this is 1, and then from 1 to 3, it is decreasing, so it's like this. And then it is increasing again from 3 to infinity. Right? So that's how you would do it, and you can see here that this is increasing, this is decreasing, and this is increasing. So that means that right here, because it's in between increasing and decreasing, there is a maximum. And then right here, because it is between decreasing and increasing, there is a minimum. Because you see it goes increasing, and then it's decreasing, and then increasing again. So it looks like this. This is at x equals 1, and then over here, it's at x equals 3. So this is decreasing, this is increasing, this is increasing, and then you see here that there is a maximum. And over here there is a minimum. So that means that the minimum of this function is going to be at x equals 1, and the maximum will be at x equals 3. Now let's do another one, okay? I really just want to make sure we understand what this means before I move on, like with the next video, or before I end this, because I really want to make sure we understand this. We're just going to do one more example, and then that'll be it. So, let's see. Give me 1 second, guys. My bad, guys. It's supposed to be minimum at x equals 3. So like this. And then maximum at x equals 1. Okay. So that is how you do it. I would do more, but I would say that this is the most basic function to do, to do one of these. If anybody has any questions, or if you want me to go over more, let me know, and I will. Let me see, hold on. I'm trying to see if there is maybe one more I can go over. I mean, yeah, I'm just gonna stop it right here, guys. Again, if anybody has any questions, let me know. So if you want me to go over any more of these, I can. And thank you so much for watching, guys. And again, if anybody has any questions, let me know. In the next video, we are gonna learn how to find second derivatives. So that is before we get into concavity and inflection points and stuff like that, which is really exciting. But before we get to that, in the next video, I'm going to do second derivatives, okay? So with that being said, guys, thank you so much for watching, and I will see you guys in the next video. Bye, guys.